Hello, geometry. I want to show you what I just purchased from the store just for you guys in the video. You ready? Aren't those pretty? So I do have my erasable pens nearby in case needed, but I do love the way these write, and they're very vibrant. So we're gonna give these a try. Huh, how exciting. Now, I will also be giving you some other problems throughout this video. So have a paper and pencil, have your review packet, feel free to work them, but the extra ones I would suggest stopping the video, working them, and then checking your work. I will also be giving you that wonderful list of theorems that you can use for the test at some point in the video. I wouldn't want to give it right away. That would make things a little too easy for some of the students in the class. So, let's get going. Okay, state the postulate or theorem that you can use to prove each pair of triangles congruent. If the triangles cannot be proven congruent, write not enough information. Okay, so we're trying to prove triangles are congruent. Number one, what are our triangle congruence theorems? We have angle, angle, side. We have side, angle, side. I'm less than impressed with this purple one. Angle, angle, side. Missing one. Oh, hello. I'm so worried about my pen. And now it's not erasable, but good thing I have my... Oh, what is going on here? I'm out of my thing. No way. It's ridiculous. There we go. All right. Angle, angle, side, side, angle, side, angle, side, angle, side, side, side. And of course, then we have the AHL, which is specifically for right triangles. Okay, so those are the options if they work. Remember, there's a reason the A is in here. It shares, this angle makes up these two sides. And there's a reason the side is in the middle. It makes up these two angles, touches them both. So we can mark things like reflexive, and we can also mark vertical angles, because those are things you can tell by looking at the picture. So when I look at this, I see boom and boom. Those are vertical angles. Then that gives me enough information to be able to say side, angle, side, and side, angle, side. All right, let's look over here, and we have reflexive. So, does that give me enough? Angle, side, side. Side, side, angle. No naughty words are listed here, are they? So there is not enough information. Right? Remember, we do not have an ASS theorem. Okay. Onward. What is the measure? Switch. I'm already sick of that one. Okay, what is the measure of angle X? Well, first thing is you need to look at and analyze what you have in front of you. You have what? An isosceles triangle. So, therefore, if I have two sides, the isosceles triangle theorem tells you that if you have your two sides are the same, then their base angles are also the same. So that would be 35 degrees. Okay, and what do I have to figure out here? Still measure of angle X. So here the measure of angle X is 35 degrees. Okay, so these are the same, but I don't know either one, so it's not going to work like this. But I do know the triangle sum theorem tells you that all three angles add up to 180. So let's just say this is x and this is x. 94 plus 2x's is equal to 180. Subtract 94. We're left with 86. And we get 43. So measure of angle x equals 43. And a lot of you may not necessarily have to work through all that, but you notice that, okay, these equal 180. I take away the 94, I see what's left, and I divide it by 2. All right. What is the value of x? Okay, so analyze what you have. I have an isosceles triangle. Again, only it's upside down. So the base angles would be the same, so that's 30 and 30. Again, I know that triangle sum theorem tells me these all add up to be 180. So 30 plus 30 is 60, plus x equals 180. Subtract 60, and I now know that the measure of angle x is 120 degrees. Actually, that's a lie. That's the measure of angle z. They trick you, don't they? Look at that. X degrees and angle z. We'll talk about confusing. All right, let's get rid of that. X equals 120. Onward to this one. Let's see what we've got here. Again, analyzing. Okay, I see that I have an isosceles triangle here. That. Again, an isosceles triangle here, and I have that. But I do know these would be the same because those are vertical angles. So if I can figure out this one, then I've got that one. And since it's an isosceles triangle and this is 50, this is my other base angle here, so that's going to be 50. And 50 plus 50 is 100. And the whole thing has to be 180, so that means this one is 80. Which means the vertical angle is also 80. All right, how about if I gave you, I'm going to give you a different one now. What if I gave you triangle, so grab your piece of paper, and I said this. Don't go by my beautiful drawing here, go by my markings. X, Y, and 60 degrees. Could you figure out X and Y? Yes, you could, because you can see this is an isosceles triangle. So if this is 60, that means this is also 60. And hence, actually, this is also 60. So not only do we have an isosceles, which I marked, but now that you've figured out all three angles, you know that you actually have an equilateral triangle because all the angles are the same. So equiangular and equilateral. All right, how about this one? What if I give you a triangle like this? Pause the video and do that one. Okay, it may at first confuse you because you see an X and a Y and you're like, oh, what am I going to do? But then you notice that it's equiangular, and then you know, okay, all the sides are equal to each other. So if I know this, I can either set this equal to this or this equal to this. It's not going to matter, but I can figure out my X and my Y. 48 equals 4X. So X is 12, then 48 equals 6Y. Y is 8. So there's my two answers for that. Okay, all because I knew these meant that you have an equilateral triangle because it's equiangular. Okay, one more. Figure out the angle measure of no, not figure out the angle measure. tell me what x is. Stop the video, do it. Okay, you should have noticed that. Again, it's equilateral. So I know each of these is going to be what? 60. So I could either do 2x plus 2x plus 2x equals 180, but I'd rather do 2x equals 60 because I knew that each angle would have to be 60. 180 divided by 3. And so that means x is 30. Okay, excellent. On to the bottom part here, congruent. Okay, so let's be clear when it says what are the congruent corresponding parts. So just to be clear, in our last chapter we had this kind of picture, and we talked about corresponding angles that would lie like that. Here when we're saying what are the congruent corresponding parts, we're saying they have to be in the same position of each one. So in other words, in this figure, these are not triangles, right? These are four-sided figures. There's four vertices. So I'm actually not going to have 6 things, 3 angles and 3 sides. I'm going to have 8 things, 4 angles and 4 sides. So I'm going to start by looking. Angle R is congruent to angle W. Angle S is congruent to angle X. Angle T is congruent to angle Y. Angle U is congruent to angle Z. Then I go over and I have to get all my segments. So make sure you put the segment bars above them, please. So we have RS is congruent to WX. Good. ST is congruent to XY. TU is congruent to YZ. And the last one is these outer ones. RU is congruent to WZ. They have to be in that order. They have to be listed correctly. I cannot say RU and ZW. No. Okay, so if I gave you this, or I gave you 3 pictures and they look kind of similar, so it's kind of hard to tell, you know, what's what as far as congruence. Is it going to be easier to figure out what's congruent by looking at the pictures or what's congruent by looking here? Definitely here. Always, if you're given this and the pictures, always use that to come up with this stuff. Always choose that. Pictures can be deceiving sometimes. Or they can be written by me and just be bad. And very, very poorly written. Okay. Let's do this one. I look at that and again I say, oh wow, okay, it's an isosceles triangle again. So the converse of isosceles triangle theorem says if 2 angles are the same, then those sides are. So I'm going to set them equal to each other because they are indeed equal to each other. On my line. Hoping your solving skills are just amazing at this point. So x is 4. I looked back because I wanted to make sure it didn't say what's the side length, but it didn't. It said what's the value of x. If it said what's the side length, of course you'd plug it in. 7 times 4 is 28, minus 10, 18. Okay, a couple for you to try now. All right. If I give you triangle ABC, tell me the angle included between AB and AC. Okay. What angle is included between AB and AC. And it's going to be the one in common, right? The A is in both, so angle A is your answer. Okay, what sides, wait, how did I write this? I have all these scribbles here, hang on. What sides are between angle D in triangle DEF? Okay, again, it'd have to include D. So it's going to be DE is one of them, right? And the other would be DF. All right, now let's go back up to this. What side is included between angle A and angle B? AB. Remember, a side is a segment, and included is right between those two things. So the only thing between angle A and angle B is the side AB. Okay, now BC, same thing here. I'm going to go up here. BC is between what two angles? Angle B and angle C. Good. All right. Turn page. These should go kind of fast because, oh, well, and here's an example of what I was just saying. I said here's the, well, that actually got crossed off. That should be a triangle. So you're given this and you're given this. What should you use? This. These are really similar. I mean, you probably can tell, but this is just a safe bet. So angle S, angle G. Angle E, angle T. G, R, you got to go in the right order. S, A. A, T, excuse me, R, E. Triangle. See, I'm noticing we have angle, segment. Now I'm triangle, E, R, G. E, R, G. Same order over here. T, A, S. E, G. T, S. Triangle, R, E, G. R, E, G. Same order. A, T, S. And angle R is congruent to angle A. All right, so hopefully you got those down. All right, can you prove these two triangles are congruent? If so, write the congruent statement and name the postulate you'd use. If not, write not possible and tell what other information you would need. Okay, so let's take a look at these two. Okay, I say I have two angles and a side, but let's make sure they're in the right order on each of them. So this angle, side, this angle. This angle, side, this angle. Yep, so this side is included between the two angles. So it does say to write a congruent statement, so I got to put them in order. So triangle, I'll just say NTY is congruent to triangle. Now I said N here, so I got to start with the J here, the one that had nothing. And then I went to the double ring, so I got to go to the double ring. Single ring. Now you can write these in different orders, but when I check them, I always check to make sure the N and the J are in the same spot, the T and the S are in the same spot, and the Y and the W are in the same spot. And why would they be? By angle, side, angle. Congruence theorem. Good. All right, we look at 16. Again, you can mark which two things? Reflexive and vertical. Notice the spelling. All right, so we have reflexive right there. So again, side, angle, side. Side, angle, side. Yep, that works. Be careful, because if I would have said this angle and this angle, that wouldn't have been it. Side, angle, side. It's got to be the included angle. So we know it's SAS, but I got to still write my congruence. A, L, E is congruent to a triangle. So I started with this curve, L, and I went to the, wait a second, AL. So I went LAP. Okay, 17. Another reflexive. So I have angle, side, nothing. Angle, side, nothing. So not enough information, or not possible is what it says. Okay. What else would you have to have? Well, a couple options. One would be you could have LR congruent to AP. That would have been side, angle, side. Or you could have had this angle congruent to this one. So angle RAL is congruent to angle RAL. Either one's possible. Going over here, we have reflexive again. And then I have 1, 2, 3, 1, 2, 3. Good. So these are SSS, congruence theorem. And again, I have to go in the right order. So AOC, oh dear, is congruent to CNA. All right. State whether these figures are congruent. State whether these figures are congruent, justify your answers. So ABF to DEC. Yeah, I would say they're definitely congruent. And it says justify that. Well, and there's a bunch of things you could have put. We have, they're right triangles. They have a leg and a hypotenuse. So you could have said HL. You could have said angle, side, angle. You could have said side, side, side. You could have said angle, side. Any of them would have worked. Wow, that's a hard one to get wrong, isn't it? So any of those would have worked. Let's look over here. Ooh, this is no. Did you guys get that? Or did you put yes, SSS? It is not SSS. Look at, these are the same. You gotta have different pairs. This doesn't match. This doesn't match. They match each other. That's not helpful. I need them to match in the other triangle. So that is not SSS. All right, look at, oh, we got a fourth thing going on here. Okay, well, that's fine. We can't use these if we have four sides. These are just for triangles. But remember, the definition of congruence means all parts are congruent. Right? So if I have four angles and four sides that are all congruent, then they would be. So let's look. So I got 1, 2, 3, and this is reflexive. Wow, 4. Now it just matters about the angles. So I got one angle here, I got two angles here. This is 120, so that means, let's see here, that's 120. Are these, oh, it is a reflection. Okay, so you know it's a reflection because of these being the same. So it reflects right over. So that's going to be 60. That's going to be 120. So this would be yes. Definition of congruence. Congruent figures. That's kind of an oddball. I don't usually throw those in there, but it's good to remember why we do that. All right, how about this one? Well, we can put the sides in there. Oh, and then they give us these sides. See, the 4s? So that's another one. So we can say definitely yes. We can do SSS. We can do angle, side, angle. And we have side, angle, side, yeah. What's the only one we can't do? The HL, because we don't have right triangles. All right, next one. This page seems a little simpler. Lots of these types of things. So GH is corresponding to XAX. And angle W is corresponding to angle F. And angle T, the third one, is corresponding to angle K. and THPA. THPA. KEBI. KEBI. So hopefully you guys are getting those right. Triangle hot, triangle sun. O is congruent to U, and T, of course, is congruent to N. What's the relationship between S and H? Well, S and H are corresponding parts, not corresponding angles. They're corresponding parts. I mean, there are actually angles as well, but so we can say they are congruent. And if O is 27 and T is 63, what's S? Well, that's 27, that's 63. So we have two of the angles in a triangle. So 180 minus 27 minus the 63 leaves you with 90 degrees. Onward. Oh, then we get to the overlapping. So, gotta be a little careful. Hang on, I need a drink. I'm sporting some Zevia Cola. I highly recommend it. It is flavored with, it does contain caffeine, as you can see, but it is non-GMO. 0 sugar. But it doesn't have garbage sugar in there. If you notice, it has a little zoomer on there. Right. Stevia leaf extract, which isn't the garbage. So that's good. So I highly recommend that. Costs you an arm and a leg, but hopefully you'll be healthy. Okay. Name a pair of overlapping congruent triangles in each diagram. State whether they are congruent. Okay, so when we look at this, I'm hoping, and I'm going to get my erasables out for this part here, so in case I need to erase. So I'm hoping you can see this triangle right here. So that's one of them. So that's triangle ORA. And then I'm going to put the other one in green. All right, and that's right here. So that would be FAR, triangle FAR. So let's just see if we have these labeled right. I want to make sure. Ours, yeah, okay, we're good. So can you see anything that overlaps between the two? Anywhere? Of course, it crosses over right there, but that's just a dot, so that's irrelevant. But this whole side right here has pink and green, so that overlaps. So I've got this triangle right here. That's a FAR. And then I've got this triangle right here. I'm just going to draw it right there. And that's ARO. So when we write this overlaps between the two. We're saying those are the same. It also is telling us that this is congruent. And because these are all the same, these are both doubles and these are both doubles, this and this are the same. So I can mark that. And I do have them congruent by HL congruence theorem. So now on this one, it doesn't actually say you have to write the congruency statement, but remember you can only use this with right triangles when one leg and the hypotenuse, which is across from the right angle. That is the hypotenuse. Okay, so let's go on to this one now. We have this triangle right here, triangle MQR, and then we have this one right here, MQR, so SRQ. And are they congruent? I don't know. Let's take a look here. we definitely have this reflexive part right here. Let me use 3. Oh, 4, I guess. So let's see if any of them are the same. So I've got one side. So if it is hard for you to see, rewrite them. And then you can kind of mark them. I know I have this reflexive side right here. And then I've got this other side. I don't have any angles, but I do see that this long part right here is a 1 and a 2. And I see this long part here is a 1 and a 2. So those are also the same. So these are congruent by side, side, side. Okay? Hopefully you're starting to see these. Here's this triangle. And then we have this triangle. So now there's no complete side overlapping. Let's make that clear. We have parts of sides overlapping, but not the entire side. The only thing that's overlapping is this angle here. That is in both triangles. So you have this triangle and you have this triangle, and I always write them exactly in this, laying out the same direction so I can see them. Now what else is the same? I've got 2, 1 and 2, 1. So those long sides are the same. And then I've got this angle and this angle. So whoops, I didn't put my congruence statement. So it'd be triangle AON is congruent to triangle, let's see, AON. So that'd be MOP. And if they're congruent, which I already put they were, but why? Angle, side. No, I'm sorry, angle, angle, side. Angle, angle, side. Okay, good. All right, last one. Well, actually, there's more here, sort of. Here's one triangle. Here's another. What overlaps? Okay, parts of sides, but the only full thing is this angle right there again. So again, if it helps you, rewrite them. So we have this, and then we have, this one's a little harder. Wait, actually, I'm going to put it down here. Right here, and oops, these are the same right here, those two. So, oh, goody gumdrops. This is the same right here, or is that the whole side? Oh, the whole side. Okay, this whole side is the same as this whole side. You know how I know it's the whole side, not this part, is because they center them, and this is not centered on here. It's centered on this whole long side. So I do have a triangle TGR is congruent to triangle OGS. And why? Angle, side, angle. The side is included between the two angles. Excellent. Identify any common angles or sides for the indicated triangles. Oh, okay. So it's kind of what we were just doing, but what overlaps? So you can do the same thing and say what overlaps. DC. That's it. You can say CD, DC, either way. And then here's this picture, which you should be getting used to hopefully by now. And the common is there's no side that's fully overlapping. You just have angle J. That's overlap. Okay. All right, find the value of each triangle. Okay, so here we go. Look at what we have. We know this one's 2x plus 10. And we know we have 3 of them. And we know it's an equilateral. So again, there's 2 ways. You can either multiply this by 3 and equal 180, which is longer than just simply saying, okay, if it's an equilateral triangle, 180 divided by 3 is 60 degrees. So each angle is going to be 60 degrees. So I can take that and set it equal to 60 degrees. And x equals 25. All right, I'm bored with that. All right. let's look in this one. What do we have here? We got this is 25. We got to find x right here. Well, if that's 25, I see this. So I see that big triangle is isosceles. So isosceles triangle theorem tells you if that's 25, then this is 25. So together these are 50. So this whole big triangle, 180 minus 50 equals 130. And then we split this into 2, equal 1. So half of 130 divided by 2, and you get 65. Equation-wise, if you're an equation person and that makes more sense, I'm adding these 3 angles and solving that. Because this is x, so this has to be x because they're marked the same. Okay, next one. Let's figure these out. Okay, we got, what do we have here? We have an isosceles triangle, and I have a linear pair. Don't forget about the linear pair theorem. It tells you that if you have a linear pair, then they are supplementary. So 180 minus 135 is indeed 45. So this is 45. Isosceles triangle theorem tells you if these are the same, then the base angles are the same. And now I know triangle sum theorem tells you all 3 of these add up to 180. So 180 minus the 90 here is 90. So list them all out though, so I can clearly see that y is 90, and x is 45, and z is 45. When you're done with these problems, if you can list them and put them, circle them, that's great. All right, let's start the proofs. Now, whoops. There's some other things involved, and when we're done with these proofs, or somewhere in the middle, I'm going to tell you which theorems you need to put on your list for the test, okay? All right, so statement, reason, yes, copying the whole thing. Wow, there's a lot in this one, isn't there? Okay, so that's given. So let us remember a couple things. They don't tell you something's a midpoint just for fun usually. So let us decide what information that gives us. If M is the midpoint, well, okay, halt. We always want to see what we're trying to prove first. ACM. We're trying to prove ACM is congruent to right here. Okay, so let's keep our eyes on the prize. We want to show those 2 triangles are congruent. And when M is the midpoint of AB, that means it's in the middle. Those have to be the same. AM, make sure you label them right now. AM, BM, oh dear. And that is by definition of midpoint. Okay, so we're getting somewhere because I can see that I have a right triangle. Although I haven't said I have right angles yet. I have to do that because in order to use the HL theorem, which is where I'm heading, it's saying you have 2 right triangles, and I haven't stated I have right angles yet. So I have to go do that. It says they're perpendicular, but it doesn't say it's right. So angle ACM and, no, notice I'm not putting they're congruent, and BDM are right angles. What would I put there then? Definition of what? What was up here? What are these? Perpendicular. Okay, so we got that stated. So we got the right angle stated. We have the hypotenuse stated. Somehow we got to get a leg. And maybe we won't use HL. Maybe that's not where we're going to go, but that's where I'm thinking. So what other information? Oh, I didn't mark this yet. So we've used this We've used midpoint, we've used the perpendicular, but I didn't mark that yet. So we got 1 and 2 that are the same. That tells us something about this triangle, doesn't it? It's an isosceles. And there is a theorem that tells you if the angles are congruent, then the sides are. What one is that? Yes, the isosceles, no, the converse, right? So we can say those two are the same. CM is congruent to DM by the converse of the isosceles triangle theorem. Good. And then, do we finally have it? Hypotenuse, is that the hypotenuse? Yes. And a leg of two right triangles. Yay! We did it. Oh, what am I doing here, people? All right, let's take a look at our other ones. Wow, I gave you good practice on these, didn't I? So, first of all, this is supposed to be congruent. So I hope I remember to tell you that in class, because that is supposed to be congruent. Okay, so let's look at this statement. Reason given. Okay, just want to make sure, let's see, 1 and 2, and 3 and 4, and AP. Okay, now, where are we heading? ABP is congruent to, all right, so we're trying to get those two. So what do we have so far? We clearly have an angle and a side, angle and a side, and we need something else. Oh, but we, you know, you may look at this and go, okay, I have an isosceles triangle, so the converse we just said would mean these two sides are the same. But do we have an ASS theorem, people? No, naughty words, no. So that's not going to help us. But we do see that we have a linear pair. We have a linear pair. So we know these are supplementary, and since these are equal, then these are going to be equal as well. So let's get that down. Why did I do that on there? I put that on the answer key, though. Why did I do that, you guys? Trying to... Supplementary angles theorem. There we go. Angle ABP is congruent to angle DCP by supplementary angles theorem. All right. So I can mark that. And then I have angle, angle, side, and angle, angle, side. Yippee. We are done. Don't worry, it's not going to be on the test, but that's pulling it out from the past. But it's good to practice the different things. So, see, in mine, I actually did put these two sides are the same. You know, I guess you could have done angle, angle, side then this way as well, but we can't do this. No, no, no. Okay, so now we got two more proofs to go. Let's see here. We got a statement and reason Okay, oh, another long given. Don't you love it? Oops. So PD is congruent to PC. P is the midpoint of AB. Okay, so 1 is congruent to 2. Use different colors. And 3, oh, 3 to 3. Nice. Okay, what happened to my erasable pen here? It's not erasing. There we go. And then 3 to 4. And PD. And where are we heading? Let's look. ADP. Okay, so we're trying to get these big guys congruent. Okay. Well, like I said before, we're not going to tell you this information just for the heck of it. It means something. So P being the midpoint of AB tells you that these are the same. It's right in the middle. So AP is congruent to what? EP, good. Definition of midpoint. Now the next one's a little dicey. So when we get to the next one, I mean, if you can see, we've got this and we've got this, we've got this and we've got this. And then we have these are the same and these are the same. So ultimately these are going to be the same. And it's kind of a mix of, again, this one, I'm not going to put one quite like this on the test, but you're combining these by angle addition property and then substituting in. So it's kind of a double. So I guess I can write this out. We haven't done that one for a while, so. And then I'm going to substitute the value in here. So angle, let's see, APD is congruent to angle APD, BPC by substitution property. And then lastly, we're going to have a triangle ADP is congruent to triangle BCP. Side angle side congruence theorem. Side angle side, side angle side. Lastly, come on, you guys gotta admit, these are kind of fun. They're like little puzzles. And there's always a way to start them, so you don't have to just stare off into space. You know to start with the given. You know to go in and mark it. And you know to go see where we're heading. PAB. PAB is isosceles. Okay. So basically, do you guys agree with me? If we're trying to get this big thing to be isosceles, two things. If I can somehow get this side and this side the same, I'd be able to say they're isosceles. Or if I can get this angle and this angle, I could eventually get back to it being isosceles. So somehow I got to either get these sides or these angles. Okay, well, I'm going to guess the clue here is to somehow work to get these little triangles congruent on the outside, because once we can say the two triangles are congruent, I can certainly then go ahead and say the parts of them are, right? But I still don't have enough. So I've got to, if I look at these two little triangles to begin with, not for the final thing, but just for now, I've got an angle and a side, and somehow I got to get another angle. But I do know that this inside triangle is isosceles. So therefore, I can go ahead and say these angles are the same. Angle 1 is congruent to angle 2 by what? Exactly. Isosceles triangle theorem. So those are the same. Okay, so then if those are the same, we can say 3 and 4 are the same by that theorem we just used earlier, supplementary angles theorem. So now I've got these equal. So now I've got the ticket for these little triangles, don't I? Angle, side, angle. Angle, side, angle. So all right, so those triangles are the same. Our point of doing that, remember, was because now I can say that parts of it are. So I can go right over here and say, oh, good. I'm going to pick those two because those are the two I wanted to be able to show this whole triangle is isosceles. So PA is congruent to PB by what, though? We just showed the triangles are congruent. So we're now saying a part of them is congruent. So that's CPCT theorem. This is great news, isn't it now? Because look what we just did. We just said that on this big triangle I have two sides that are the same. And that means what? That means that it's isosceles. Yay! By definition of isosceles triangle. All right, let me make sure I didn't miss any of my other notes. Oh, I do have a note here. What did I write? Let me see what I wrote about. Oh, I think I already mentioned it, that if you're going to use the HL theorem, that must have been on one of these other ones. Oh, I think I did talk about it down here. If you're going to use the HL theorem, it has to be stated that you have right angles. But if you're going to be, like, instead of HL, if you were going to do, like, SAS, ASA, SSS, any of those other four, it's not okay to just say this. If you're going to, because sometimes, let's say you have, let's say I didn't have this. Let's just jump ahead here and let me just show, oh, this is just fantastic that I used the erasable there. Okay, let's just say you had this. Okay, so just look at these two triangles right now. That is not congruent by HL, is it anymore? What are these congruent by? Side, angle, side, and side, angle, side. So my point is, when you're going to use like SAS, ASA, angle, angle, side, or SSS, well, you wouldn't use SSS because there's no angles in it. You can't just have it be enough to say right angle. I would have had to do one more step in here and said angle C, I'm just going to write it down here because there's no room, is congruent to angle D, definition of right angle. Okay, that would have had to be in there if I was using one of these. You don't have to say they're congruent when it's HL because it's part of the HL theorem that it's two right triangles, and you've said that. But in these, you're talking about angles that are congruent. So I have to go to that extra step and say the angles are indeed congruent. All right. Now, to the part you've all been waiting for. I was going to put it in the middle to hide it somewhere in there to make sure you watch every minute, but you guys are just so wonderful. I'm sure you wouldn't have thought of not watching any of this video. So here is the grand finale list. These are this is the list you're going to be able to use for the test tomorrow of the theorems that are on it. So for triangle congruence theorems, those are theorems that we can show the triangles are congruent. So that means you would have a congruent statement. We have the ASA, SAS, SSS, and angle, angle, side. Wow. We also have the HL. But again, that's just for right angles. So this is, you can copy down what's on my paper, and that's all you'll be able to use. Here you also have, so you have those theorems, and then you have the isosceles triangle theorem. And you have the converse of the isosceles triangle theorem. I'm not going to put the picture, but you guys need to know which is which. This is where you have the two sides, and you conclude the angles. This is where you have the two angles, and you conclude the sides. All right, and also reflexive property of congruence, definition of right angles, definition of perpendicular lines, I should say, definition of midpoint, and definition of bisector. There, they're all on there. So that is it. Nothing more, nothing less. Well, you can have less if you want, but you can't have more. You can't have any additional notes on here, so don't do that. All right, cool. Hey, under an hour. Pretty good. All right, take care. See you in class.